Hi, Kaiman. All right, to address your questions, the mean value theorem does not require, so you said the variables a and b end on the same y level. So let me be a little bit more precise with that. So let's say here's the xy plane, right? And a and b are not variables. X is your variable. X and y are your variables. So let's say a is some number here, some constant, some specific x value, and so b is over here. And so when x is equal to a, there's some point on the graph, and the y value for that is f of a. Okay, so if so the short answer is no. The mean value theorem does not require the y values f of a and f of b to be on the same y level. So maybe this is f of b. And so there's some function that goes through these 2 points, and it probably keeps going this way, and maybe keeps going this way. And what the mean value theorem is saying is that the slope of the secant line that connects these two endpoints, the mean value theorem is saying, well, there has to exist somewhere in the interval a and between a and b some other number c, so that the slope of the tangent line when x equals c is the same as the slope of the secant line. All right, so this is what the mean value theorem is saying. If f of a and f of b, or these two, the starting point and the end point, if those two y values are on the same level, we call it Rolle's theorem. So Rolle's theorem is just one specific case of the more general mean value theorem. It just says it shows the existence of this number c. Now there's two requirements. The function f of x has to be continuous on the closed interval starting with a and ending with b. Also has to be differentiable on the open interval. So the derivative has to, so what this word here, differentiable means the derivative has to exist, or cannot be undefined. In this case, in the interval 0 to 1. So first of all, the question is, what is the derivative? If we bring this down here, f prime of x equals 3, so according to the power rule, 3/4 x to the negative 1/4 power, or we could write that as 3 over 4x to the 1/4. Okay, so that's the derivative. Now, if the function is differentiable when the derivative exists. So the question is, when does the derivative not exist? Well, this is a fraction. So f prime of x, or the derivative, doesn't exist when x equals 0, because if x is 0, you get 3 over 0, which is undefined. But 0 is the endpoint. So we need, let's change this to blue, we need f of x to be continuous on the closed interval a to b. And we need f prime of x to exist on the open interval a to b, meaning it has to exist everywhere between a and b, or in this case between 0 and 1, but not necessarily at 0 and not necessarily at 1. In this case, the derivative exists everywhere except x cannot equal 0, but that's fine because that's not on the inside of the interval. So we would definitely say yes. The function is continuous on the closed interval and differentiable in the open interval. Okay, I hope this helps.